Thank you so much. I got started looking at window functions back in 2012, whenever Microsoft made a big investment in this area. And I had been doing a session at a lot of events on window functions, but what I found was now all of a sudden I had too much material and I broke it into 2 sessions, and I've done half-day events on this topic before. So what I'm going to talk about today is the performance of these functions. And hopefully you don't think I'm talking about the Windows operating system. These are special functions that you see with T-SQL. A little bit about me. You heard him say I'm the editor at Redgate. And the most important thing to really know about me is that I'm a lifelong learner and a teacher. I love learning new things. In the past year, I've taken up some new hobbies just because I love learning things. And I don't care if I'm not that great at those things. I just love learning and just discovering new things about technology and just, you know, things about life. Things like cookie decorating, for example. All right, so since this is a 50-minute session, I'm going to assume that you have some knowledge of window functions. So probably most everyone here has at least seen row number before, but there are quite a few others. And I'm not going to go into how these work. I'm just going to concentrate on the performance. And if you're not that sure about them, there are videos of me talking about the introductory session on this, probably several of them out there if you go do a search. And I've got some resources at the end. So I'm going to go ahead and just start with the demo here. And I'm going to use AdventureWorks 2019. And also I am going to stick with SQL Server 2017 compatibility for now. And I know those are all done. So what I've got here to start out with is one of kind of each type of window function. I've got a query with a row number. Okay, I've got a query that's got a window aggregate. I've got a running total. I've got one with lag. I've got one with first value, and I've got one with percent rank. So what I'm going to do is just run all of these and without making any optimizations, just to see where the problems might be. I'm going to look at 2 things. I don't care about the results, but I am going to take a look at the statistics IO and also the execution plan. So for all of these, they're all looking at the same table. They all have, for the table, logical read 689. That's because I'm doing a scan of that table, and that makes sense because I don't have a where clause, so a scan makes perfect sense. So each of these are 689, but they all have a work table. So a little work table under the covers that SQL Server is using to help come up with the results. And that's kind of similar to like what Monica had talked about in the last session using a temp table. That's kind of what it's like. But notice in some cases, the logical reads are 0, and in other cases, the logical reads are a big number. Okay, so when I'm doing query tuning, this is one of the first things I look at because it typically will tell me that there's a lot of IO going on, and this query is, you know, logical reads is really kind of an indicator of the performance. These are small tables, so it's just kind of really surprising to get this gigantic number here since the table is so small. Let's take a look at the execution plans as well. So the very first one, what I really want to point out is that the sort is taking up the 80% of the resources in the very first one. And if we look at all of them, we'll see that the sort is being reported is quite a bit in every one. I'm going to tell you that with window functions, the execution plan will lie to you a lot. We can't always trust it. And I will explain what to look for and why that is. Another thing I want to point out, and this is the window aggregate, we've got these things called table spools. That's a red flag for me. When I see those, I know that that is bad news. What that means is the work table is being created on disk. Even though it says the cost is only 2%, it's actually much, much higher than that in real life. I'm not sure why they cost it like that. I might see window spool. Window spool might be good. It might be bad, but the cost is always going to show low. So in some cases, it really isn't. And this is where you really get a lot of misinformation from the execution plan. But in all of these, the first thing we notice is that there is a expensive sort. Why might that be? Well, if I look at all of these, we have all of these have a partition by. Okay, they all have the same over clause. Where it's needed, I've got an order by, because the order by is not always required, not like with the Windows aggregate, that you don't have one there. So under the covers, SQL Server has to sort this by the partition, even if we don't have an order by. So this one right here, no order by in sight, but SQL Server still had to sort that because of the partition. All right, so what can we do about this? Go back to the slides and just take a look at all the different types. And what I've done is I have marked poor performance where we see those big statistic IO numbers, where we see the high numbers of logical reads. We have okay performance on ranking, lag and lead, actually only those two. Okay, the other ones we are seeing a high number of logical reads. These are really small tables, so it's hard to see the performance difference, but if you were working with a very large table, you would see it right away. All right, so the first thing that you can do is possibly add an index. And as far as I know, Itzhak Ben-Ghan came up with this POC index. And that's where I first learned it from. So I'm going to give him credit. You can use this to help eliminate the sort. It can help all the types of window function queries. However, what I've found is that it doesn't always get rid of the sort, especially since you have to put any columns that you're filtering or joining on at the beginning. You're still going to end up with some sorting. But if this is a covering index, you're still going to see a benefit. You still might see the sorting, but it can help over using the clustered index. Seems like there was something else I was going to say. Oh, what I'm going to say is don't automatically add an index every time you're using a window function, because you could get way too many indexes. You've got to add indexes, with it's an art and a skill. Be careful about adding too many. If there is a query that you really need to tune, it's really important that this query performs as well as possible. You may consider adding an index like this. Okay, I'm not saying do it across the board. So let's take a look at what happens when we add an index. And actually, I only have to add one in this case, because this particular one will help all of those, because they have the same partition by, order by, and the same columns in the select. So we've got our customer, that's the P, sales order ID, that's the O, and I've got an include here with order date and total due. That's the covering part. Doesn't have a where clause, doesn't have a join. And in real life, most of the time you will have where clauses, you will join. So that's why I'm saying that this helps some, but not, not 100% of the problems are going to go away. I'm going to run this again and see if we have, I've got that on there already, but see if there is any difference. So I'm going to come over here and take a look. And the very first one, it's really happy. We're down to 119 logical reads. And it is so happy because now we are, let's take a look at the execution plan really quick. What's happening is instead of scanning, we're still scanning, but instead of scanning the cluster index, we're scanning a small non-clustered index. And our sort is gone. So this is the perfect scenario. Do perfect scenarios happen all day long at work? No, they don't. So take this with a grain of salt. You may see improvement, you may not. All right, so the window aggregate, in fact, in all of these, we've got this logical reads for the table decreased quite a bit, but our work table is still really high. What that means is for those particular types of window functions, they are not necessarily going to scale. If I am running it against a 1,000,000 row table, it might make more sense to use one of the older types of techniques, like using a common table expression or a temp table, something like that. I'm not done yet. I still have more things to show you. So we still, we have improvement on ranking. And if I look down at lag, we've got, improvement on lag, but the other ones are still showing some problems. So let's go back to the slides and see what else we can do. First, I'll review what we've done so far. So now we've got really great performance on the ranking and the lag and lead. And just so you know, lag is my favorite function of all time. It is wonderful and it performs well without you really having to do much with it. We have gotten a slight improvement on all the other types. We still have a large amount of I/O going on, and that is a problem. So what's next? What else can we do? Next thing we can do is add a frame to some of the queries. So we're talking about moving aggregates like running totals and also first value and last value. Those support what's called a frame. So when I talk about windowing functions and I talk about like partitions, I kind of compare that to a window that has different window panes, okay? So I can have one great big window divided up into like 4 panes. Each one of those is a window in itself. But when I start using framing, it's more like a stained glass window with could be thousands of tiny little windows that my query is using, okay? Every row might have its own little window that it's looking through to gather, to see the rows it needs to work on. A lot of people haven't heard about this, and it took me a long time to actually figure it out. Again, I can thank Itzik for his work at the beginning. I just feel like without his work, I wouldn't know what I know today for sure. So the problem with framing is it's, I'm going to say, clumsy terminology. There's a lot of words to know, and you got to put them together, just right. The first thing to know is rows. It's a positional operator that we can use to define the frame. Okay, if you've ever heard of anything like rows between unbounded preceding and current row, okay, that's what you use for running total. Range. Range is a logical operator. If we do not use or specify the frame where it's needed, range is used by default. The problem with that I'll show you in a couple minutes is that remember the little in the execution plan. Let me go back and show you this. In the execution plan, where we see a window spool, if it uses range, which is the default, that means that the work table is created on disk, okay? If we use rows, that means that the work table is created in memory. If it's created in memory, we're going to get a big boost in performance, okay? So let's go back. All right, unbounded preceding means the first row of the partition. So if I'm using a windowing function that requires framing, what that means is that, and I kind of use this analogy of looking through a window, okay? I'm going to look through one little piece of my stained glass, and I'm going to see the very first row. If I have 10 rows, unbounded preceding means row 1, okay? Unbounded following means row 10. So when I look through, those are the edges, basically. And current row is the row where I'm standing, the row where I'm performing my calculation, all right? So we're going to use these to more granularly define the window that my row, where I am right now, is going to perform the calculation, okay? So here's some examples. Rows between unbounded preceding and current row. You might also hear this as rows unbounded preceding, I think. I don't ever use that. And the reason I don't use it is that it's a shortcut way of saying it. The reason I don't use it is that that shortcut like that is not available for all the situations. And I feel like this explains what's going on better. And another thing that I suggest is if you download my slides, and they're out, pretty sure they're out on my GitHub. If not, I'll make sure they get out there. While you're working with this and learning, maybe just print this, one page out, just to keep these in mind of what they mean. All right, so when I'm doing the calculation for the very first row in my partition, actually, I'm saying partition consists of one row. I should really say frame right there. Maybe I will change. Well, I'm not going to change it right now. So the rows I'm working with right now is just row 1. As I move to row 2, now I can see rows 1 and 2. All right. If I'm doing a running total, that makes sense. When I move to row 3, now the rows I'm working on are rows 1 to 3. So you can see that as I go, it just keeps getting bigger. The rows I'm working with are, that number of rows is getting larger, and every row has its own set to work on. There's rows 1 to 4, and so on. I could also say rows between unbounded following and current row. It's just backwards. This is a reverse, all right? At this point, the rows I'm working on when I'm on row 1 are rows 1 to 15. As I move to 2, my set of rows I'm working on is getting smaller. You could use this for a reverse running total. And so on. It'll get all the way to 15. I can also use numbers here. A lot of people had never really heard of like a week moving average or a, whatever. But with the pandemic, we're seeing these kind of calculations. Everybody's seeing these calculations. Well, this can be used like for a moving average or a moving sum. So when I'm only on row 1, my rows to work on are row 1. When I'm on row 2, then the rows I'm working on are rows 1 and 2. When I'm on 3, it's 3. So far it looks like a running total. But when I move to 4, now you can see what happens. You can see how that set of rows keeps moving along. Another thing I want to point out, let me move back a slide, see if this will let me do this. Nope. I thought by clicking in my other window I could do that. I'm going to do one thing here. Let me go back to these definitions. Another thing I want to point out about range is that not only is it going to perform worse, you may actually get the wrong answer. So rows, all it cares about is the position. All right. So if I'm doing a running total, it will give me a running total. If I forget to add the frame or if I use range instead, what happens is that it looks obviously kind of at the position, but it looks at things logically. So if there is a tie in my order by, it will count those as being the same thing. So in running totals, you might get some weird results. The other thing about range is that it is meant for something completely different, like comparing time periods. It's meant for something that Microsoft doesn't support yet. Okay, SQL Server doesn't support all the functionality we could have in range. And so just to kind of back up, the thing I mentioned in my regular session is that all of these window functions are part of an ANSI standard. They are defined and all the vendors can, implement what they wish to implement. So while we have range, it's not fully implemented and it can cause a lot of problems. The big issue is that people are using it and they don't really realize they're using it. Okay, so let's go ahead and jump over to get my slides back where they need to go. The next demo, where we look at what happens. Let's see, let's move down. Here we go, demo 3. So here we have a running total. Here we're just okay. So what I'm looking at here is the default frame. All I did here was say order by. I'll still get a running total, but here is what's really happening under the covers, because this is the default frame, range between unbounded preceding and current row. So let's take a look at that. If I look at statistics.io, they are identical. If I look at the execution plans, they are also identical. You know what? These queries are absolutely the same thing because I didn't add the frame here, so it is defaulting to this. Okay. What if I took that same query and specified rows between unbounded preceding and current row instead. I also can use a frame with first value. And in fact, if you use last value and you don't use a frame, you will get completely crazy results. It won't even make, I mean, it'll basically tell you the value of the row you're on, because by default, we're only, by default, our edge, it really is current row for the frame. So if we use last value, that's what it will give you. All right, so I've got using the running total with rows, using first value, I don't specify the frame, and then first value with rows between. And let's see how they work. So for the very first one where I've added rows, this is that running total that had that really big logical reads before. I've now fixed it by making sure that I have rows between unbounded preceding and current row in the query. I've improved that, I don't even know how many times, thousands and thousands of times improvement. If I use first value without the frame, I still have the logical reads, and we've seen that several times in previous demos. But when I add the frame, now my logical reads go to 0. So what does that mean? That means that because it's rows, SQL Server is creating the execution plan in memory. So why doesn't it do that even when we use rows? That would be really, really nice. Well, the idea is that when you use rows, SQL Server can tell how many rows are going to be there, and it can figure out if it's got enough memory to put all of that in memory. When you're using range, because it works with periods of time, it can't tell that ahead of time, so it creates the work table in TempDB. There are some situations where rows might also put it in TempDB if there is some kind of, not enough memory for it. I have never seen that happen, but theoretically it could. So I look at the execution plans. I'm still seeing, in fact, really interesting thing here. I'm seeing 33%, 33%, 33%. But in real life, I know that this one in the middle is taking most of the resources, the one that doesn't have the frame built in to the query. It does, but it's the default frame. So this is the one that's actually taking up most of the resources. So this 33, 33, 33 is a lie, okay? If I look at look at here, I can see that if I'm using with rows, it goes to 0. If I use first value with no frame, I get the high logical reads. And if I add the frame, then I get 0. So just by looking at the logical reads, I can tell that this is the worst performing query, even though the execution plans make it look like all three are equivalent. So let's go back and take a look and see where we are in this. And so far, what we've done is we've added the POC index and we've added a frame. Now, the frame has helped us with the moving aggregates, and it's helped us with first value and last value. It's not supported in the others. I'm kind of glad it's not, because I just do not like typing that thing out. So we still have some problems. We have problems with window aggregates, and we have problems with the statistical functions. And I have done posts where I have tried to write the statistical functions with a formula, to kind of duplicate the functionality. And under the covers, they're all using window aggregates. So that's probably why they both have this problem. So for both of those, I'm not saying don't use them, but what I'm saying is they may not scale very well for you. But we do have actually some good luck In 2019, we have this new functionality called batch mode on row store. So this is one of the intelligent query processing features. So batch mode was originally part of just column store. Query would have to have column store involved in order to get batch mode. In 2019, Enterprise Edition, it won't work in standard. Enterprise Edition, this kicks in for large queries when you're using window aggregates, okay, and the statistical functions. I also found that as long as my order by in my overclause was unique, I could skip the frame. I don't think anybody has talked about, I haven't seen anyone else talk about that but me, but you know, it is possible. So what I'm going to do, is go back and, oh, you know what? I did not finish the last demo. So let's take a look at that before we move on. Just one thing I wanted to point out is that if you are using like the moving averages or moving totals or whatever, you have to specify the frame. That's the only way you're going to get that functionality. And I'm going to run this, but it will not work for range. Range is only supported with unbounded and current row, or yeah. So this one, you know, that one works, but it's not supported with range. So this is one that situation it forces you to use the frame. All right, so in this case, I'm going to create a bigger table because that batch mode on row store is not going to kick in unless we have a much bigger number of rows. So I have my, basically it's just, I just doubled the sales order ID table or sales order detail table here and created a POC index that I'm going to need. All right, so let's see, we'll go ahead and run those two and see what happens. I'm going to run a little bit. Still not gigantic tables. But let's take a look at the statistics IO. So the logical reads for my new table that I've created, 908, but you can see this gigantic logical reads for the work table, okay? And that's because I'm using here, I'm using a window aggregate and I'm using one of the statistical functions, okay? You know what else we could take a look at is the execution plan. So you can see that nasty table spool. Remember, the table spool is always created on disk. So that's why there's so much IO. And it acts like it doesn't take a lot of resources, but it really does. And here is the one for the analytic. We've got, oh, we even spilled to disk. And we've got the table spools again. Okay, so what I'm going to do here is switch to 2019 compatibility level. Obviously, I'm running Developer Edition, so yeah, this works on Developer Edition as well. I wish that this functionality would go to standard, but you know, I've actually asked Microsoft, please put this in standard. So I don't know if they will or not. I'm going to rerun these queries that I ran before, right up there. Okay, seems like they still took a bit, but let's take a look at the logical reads. So my table is still 908, and my logical reads are now 0. And remember, these functions do not use the frame. So that's not what's going on here. It's just because of this batch mode on row store that, batch mode on row store that we're getting this benefit. If I look at the execution plan, I do see a change. Now, instead of seeing the table spool, I see this new operator called window aggregate. So that is a good thing. We like to see that. And we also see, well, we've still got a sort here on the second one. So we might want to tweak the index to take care of that. But we've got window aggregates instead of table spools. So I am very happy about that. If you are not running SQL Server 2019 and you have a need for window aggregates, like you really love using them, I really love using them. But instead, you probably should do something like this, where you pre-aggregate if you can. Even if you need to use a window function in the outer query, the lower number of rows, the better. I'm talking about window aggregates specifically. Because those are going to be really popular, but I should say less than 2019 or on standard. So the trick is pre-aggregating. Instead of doing a window aggregate over 200,000 rows, is there a way I can pre-aggregate so it only goes over 100 or 4 or whatever it is, whatever we can do ahead of time? That'd be probably a good example to show here instead of this one. So I've got one more little table here to look at. So at this point, because of batch mode on row store, I have been able to get good performance where I couldn't before. And actually, I don't know if I've got an example. Let me go back here and take one of the moving, or the, let's see, I think I'll just write a query here. Let me just take this one, even though it might not make sense, but let's just add an over clause here. Order by sales. Okay, let me just run this one. I'm going to switch back. Let me just grab that code. Change that to 140. Well, I'm going to change back to 2017 for a second. I'm going to run this one. Whoops. Sales order detail. Did I not put everything in there? Okay. Let's just do this. Say don't write code during live demos, but I just wanted to show you this. Okay, so now I've got a running total without the frame. Hopefully it doesn't take too long to run. There we go. And you can see the terrible amount of logical reads here. What I'm going to do is switch to SQL Server 2019. And even without my frame, I should get better results. Still taking a while, but you know, it's populating this grid as well. Oh, it didn't help. Didn't help in this case. That's odd. Okay, don't ever write queries on the fly, because I really thought that it would help. I have seen it help, so evidently not in this case. And I did switch. Did I run that? Let me try that again. Make sure I did run it. Try one more time. If not, I'm going to just move on, because I have seen it help before. And it's not. Okay, so never mind about that. I could be lying to you. But anyway, what I want to show you is some of the timings that I did. I had a table with 30 million rows, and I did some timings. First, I compared a window aggregate to a common table expression, you know, breaking out, you know, pre-aggregating and then just having a regular non-aggregate query in the outer query. So for the 30 million rows, and in this case, I threw the results away. I did not have them populate in Management Studio, so we were not counting that time. It took 5 minutes in 2017 to run the query. Using a common table expression to separate out the logic, it took 1 minute, almost 2 minutes. By upgrading to 2019, it took about 1.5 minutes for both. And when I ran these tests, of course, I cleared the cache out, ran them multiple times, took an average basically. So no caching was helpful. But just by upgrading to 2019, I was able to get that big amount of performance benefit. I also, when I did testing, I saw the benefit. I just didn't see it in this query I just showed you, so I'm not sure what's going on there. But when I did do testing on the 30 million rows, and left it at the default frame, it took 36 minutes to run in 2017 compatibility mode. If I added rows, did what I was supposed to do, that brought that down to 3.5 minutes. So that was a big improvement. By switching to 2019, now I'm questioning my slide here, I was able to get it down to 1.3 minutes on both of them. So I don't know if there's a cumulative update or somewhere along the way that is causing this not to work anymore. That could be, because I haven't done this testing for quite a while. And last slide I've got, I have 2 books out on windowing functions. It's got 2 books out also on windowing functions. We both did a 2nd edition in the last couple years. I've got a Pluralsight course that I created a long time ago, it seems like now. I have lots of articles on AuntKathySQL.com. And I've also put a lot of articles out on Simple Talk talking about these as well. If you have questions, I'm ready to take questions. You can also email me at kathykellenberger@redgate.com, and I'm going to check really quickly to see if I've got these slides out on GitHub. It wants me to do, I hope I don't have to, okay, good. I was like, I don't want to, doesn't look like I've got this out there yet on GitHub. I do have the slides and code for the introduction. Oh, no, I do have it right here. Okay, so let me, if I can, put it in a chat window. Or maybe, is there a way to do that? I don't really see the chat.
You can put in the private chat and I'll add it in the public
comments. Yeah, that makes sense. What am I thinking? Okay, so that's where slides and code, he'll put that out there for you.